You're listening to Let's Talk AI.
Welcome to Let's Talk AI. Today's guest is Helen Chen. Helen is a return visitor to Let's Talk AI. Helen is the director of the Practice Center for Health Systems. She is the lead of the Masters of Health Informatics at the School of Public Health Science at the University of Waterloo. Welcome, Helen.
Thank you, Howard. Nice to be back.
Awesome. So we had a great talk last time. Today, we want to make a more focused discussion on synthetic data. We see it all, in the write-ups in the paper. Everyone needs data to drive AI. I'd like for you to give us an overview of, why synthetic data, when do you use it, and then get into your program and tell us what you're doing with synthetic data.
Thank you, Howard. The synthetic data take many forms and shapes. We actually use the synthetic data many years. It's not a new thing, even in the health. And we all know that in healthcare, the data is highly privileged. It is extremely difficult to access to the data, especially for the data scientist sits outside the healthcare environment. And due to the legislation to protect the patient privacies and also all the due regulations that we need to safeguard our data in our custody. Now, without the data, there's no data science, so to speak, right? So that the synthetic data we recently get engaged to work with is really using the very sophisticated deep learning algorithm and to learn from a massive real health data, real data, and to learn their distributions, to learn their patterns, to learn their associations, and to generating another massive set of the synthetic data. Sometimes we also call them fake data. But in a way that you can think about, they are the deep fake of the data sets we have in the real, say, in the hospital or in the national agencies that are holding a massive a set of health data, right? So we are working with the hospital. For example, the Ottawa Hospital is one of our collaborators with University of Waterloo, and they offer Waterloo researchers the synthetic data of their generated from their real world EMR data. And so we can build the model and we can shift the model. We build a model on using the synthetic data, and we shift the model to be validated on the real data, and also to operationalize those machine learning models can change the health care practices to optimize to achieve the goal of even we have the machine learning to begin with, right? So that is one part of it. But also now we are getting engaged with the Public Health Agency of Canada, and we use this kind of a deep learning engine to learn from the data sets, very complex data sets in their custody, and then we can generating highly realistic synthetic data. And those data is generated, there's a few use cases identified by them. The first would have been that they can use it to share with the software developers to test their softwares, okay? So then the second is that they can also use it to exchange some data insights between the agencies.
Okay, so you mentioned data from the hospital and then data from the public health agency. Are those the same data? Are they different? What's the form of that data? Is it text, numbers, sensors, x-rays, images? What is the data that has been synthesized? Or
Okay. Yeah, thanks, Harold. So my own practice and where I encounter mostly tabular data because most of the electronic patient record data, they stored in the tables, right? Relational tables, and we call the tabular data. Okay, so that's what so far we have seen, we have used. And in the public health agency, again, it's actually the tabular data, but those data contain the types of data contained in those tables, and including, say, for example, the age, that is a distribution of, you can think about they are the real numerical data. And we also have the categorical data, such as your diagnosis. Sometimes a category can be 1,000 different types of categories those belong. So that poses a unique challenge of when your algorithm wants to properly learn and synthesize those kind of data. We also have the geolocation data. For example, you have your postal code. And then the postcode, and it turned out to be, if you want to treat them as the numerical data, you treat them as the categorical data, you treat them on different kinds. That's posed their own challenges. But the synthetic engine we employ, we experimenting, does not need to be all deal with the tabular data. So the synthetic task, for example, the GAN network and the types of data has been used first to have a success in generating the synthetic data in image, right? Those deep fake, the pictures of the people, that is actually a way of generative AI used in generating
What
highly
do we hope to
realistic
get from
synthetic
this?
data.
I mean, there's got to be a rainbow at the end of the path here. What are we chasing?
What we are chasing here, the end goal we want to have is first to develop the very good algorithm. This algorithm be able to learn the patterns, be able to generate the high quality synthetic data, right? It's usable. Usable in a way that how we say it's high quality of synthetic data. What do we mean? We mean the fidelity. We evaluate if the distribution of the variables you synthesized have the same distribution patterns of the real data, right? So that is we call the fidelity. Not only the distribution, but also correlations between the variables, the binary variables, etc. Their connection, their correlation also closely resemble the real data. So that's what the end goal we're looking at. We call it the fidelity. Then also we need to evaluate this utility. For example, if we're generating a set of synthetic data, and we use the synthetic data to build a predicting model for the mortality of a certain disease. And that model, how close that model built with the synthetic data can actually perform as well as the model built with the real data, how close they are, right? If they are close enough, would that be usable? For certain cases, yes, it's usable. But also you need to go back to the real data if needed. You want to make a decision, clinical decision, you may want to validate on your real data. But then you have already tuned up your model, you already learned how to build a model, and the validation on the real data probably will not require such a large amount of computing resources and the expertise and the time, right? So those ones are benefit of using the synthetic data to build the machine learning models. So in that way, so there's one of the example we can actually see that in Ottawa Hospital, we want to build a model to personalize the treatment for post-hemorrhage. The drugs, and we see how the effect in preventing the postpartum hemorrhage for the mothers with give birth to the baby. So we get the set of highly realistic synthetic data from Ottawa Hospital. We build the model. we send the model, the Jupyter book, send the model back to the hospital, they validate in the real data, and they actually have a model within 2 weeks, rather than we spend 6 months to get the real data and send it to us, and we build a model that go back and forth. So that is one of the very common way right now we use. You share the synthetic data, and then you build a model, you ship the model to the place which have a real data, whether it's across the institution, whether it's across the province, whether it's across the country in certain cases. And so you can accelerate this the machine learning process.
So you mentioned the post-hemorrhaging example there. What was the outcome then when the model came back? How is it the hope that the hospital can diagnose cases better, bring better healthcare? How does that affect healthcare?
Bring the healthcare, it's a learning health system. The whole concept of the learning health systems. You need to understand, you need to see your data, you need to see what the data is telling you, and then they will see the prescription patterns, the best time to apply the medication, and to say who can truly benefit from this kind of medication, right? So then you can actually target the personalized treatment, you can save the operation cost, and then that is the whole idea of you need to have data anyways. So that's in this very specific case, we look at the prescription pattern, and we look at the change of the prescription behavior. We identify what factors associated with the most beneficial use of a certain drug.
Wow, this is great. Okay. So could you walk us through another example of synthetic data, maybe?
Right now, national agencies which holding a lot of health data, such as the Canadian Institution for Health Information, CIHI, and such as the Public Health Agency of Canada, PHEC, and such as StatsCan, and holding a lot of data and sensitive data. And what they want, the few things they want, they are very interested in this synthetic data, take knowledge, and they all have these divisions, they're data scientists, and they was working in generating, kind of explore the generating of the synthetic data, right? So one of the uses is that they actually want our data scientists and the Canadian public to make a beneficial use of the data. They put lots of money and lots of people in the collect the data, holding the data, safeguard the data. But if the data is not being used, then there's no use. There's no value of those data. So they want us to use the data in a very safe way, appropriate way. But the data is so complex, right? So for example, in CIHI situation, the many tables, the connections, the requests, they will, if you request the data, they can give it to you. Many times, they just clarify your requirement, and doing the data linking, cleansing will take months and months and months. So what they want to generating a very good set of synthetic data representing their characteristics of their data and the connections of their data. And then you can do the self-discovery, right? It's very safe, and you can do the self-discovery. Instead of you going back and forth with their coordinator and with their data scientist, you actually go as a data scientist sits in the University of Waterloo. I go self-discover, and I learn the relationships, the characteristics. When I go request the real data from them, and they already saved a lot of time and effort, right? So that is one part they want to do. And I think that in the public health agency part, sometimes they are having a set of data is so valuable, but they cannot share with anybody, and by the law, right? So then with highly sensitive data. So what they want to use the synthetic data technologies for is to generating a set of very representative kind of a set of the synthetic data they can share among cross their border. They have different agencies they are coordinating, collaborating, so they can actually share the data among those agencies, but also they actually was having very a big motivation and make it as a mission to promote Canadian open data, open science initiative. So they see that publishing a highly usable, high quality synthetic data as the first step to promote the open data, open science initiative. So in a way that we are organizing, we are planning two workshops, and likely next year in February, and for sure one is in April, and in partnership with CAI, with the Public Health Agency of Canada. And what we are aiming to do, two things. First, and to actually build a community for the data scientists and who working on the generating of synthetic data to share their use cases, to share their algorithms, to share the strategies that they're dealing with the unique challenges facing within those agencies, what they are facing, the challenges they are facing. And so from the data science point of view, and we will deposit those algorithms and those Python codes, which can calculating the re-identification risk and calculating the similarities and etc. And for that as a benchmark, as a first step for this open data, open science initiative, and grow from there. And the second workshop, also very important to establish a Canadian standard. You have this guiding principle of when you can generating the data, how you generating the data, how you publish the data, how you annotate your data, right? So the so-called the model cards and the data cards. So make the model transparent. Well, it cannot be, the algorithm cannot be totally transparent, but at least you can say about how you generated, what you've generated, and what model you use as much as you can, being transparent. And the second is that for the data itself, you will be able to annotate how close they are to the real data, and in terms of fidelity, in terms of re-identification risk, in terms of the utilities when you build the certain machine learning models. And then maybe we can even publish a certain kind of a benchmarking models for you to play with it. And the third motivation for these agencies to saying, if I publish the synthetic data of my data types, and what they do is that why not I give it to the institution like University of Waterloo and teaching the data scientists incorporate into a teaching curriculum. And so right now I teach the AI for public health courses, and I almost always direct my students to say, okay, go download the MIMIC datasets, which is the US ICU intensive care datasets, and to play with it. They generating a lots of papers, and our students spend many, many hours to learn the MIMIC datasets and to build some toy models. But why can't we just use our own data sets and from CAI and from Public Health Agency, from Ministry of Health? And so through the teaching, our students already know our standards, the data format, and already probably build some very nice tools, and they can actually be shared, be used. By the time our students and goes to be a co-op, go be a data scientist in those agencies, they already know quite well of what data they are dealing with. Right? So for that, they feels like this is a win-win. They cannot give us the real data for teaching purposes. But if we do well, the synthetic data itself is going to be a very powerful education tool for our Canadian data scientists to be trained.
Wow, this is really exciting. This is really
Do you
really
need to
exciting.
go on? Something else we're talking?
No,
Yeah.
you mentioned very subtly. I'm going to track back a bit. You said something about cross border, because I know we can't send health data out of the country, but if it's synthetic, is now can we do that?
Okay, so that actually come back to the definition of what is a synthetic data, how we define them. So in the US, they actually treat the synthetic data as a de-identified data, right? If it's a de-identified data, you can share, and then they can cross a border and to share with people. But in Canada, so far, the synthetic data has been defined as a de-anonymized data, but but cross the border still, data travel cross the border still under the governance of the PHI. Okay, so there is actually still stricter regulation. You may not be able to just give somebody a set of synthetic data. So the synthetic data, we say that's the first layer for open data initiative, does not mean it's out there, everybody can use it. And it is just simply say, first of all, your privacy protection is much, much straighter. And the second, we still need to have a process to evaluate the appropriate use of this synthetic data. We still have to go through a request and approval process, but it will be a much, much shorter process.
Okay, great. So I'm gonna throw the big bad word on the table because it's starting to quietly rear its ugly head again. The word COVID. Have we learned from round one back in 2020 that, and with public patterns and health data, do we have more insight now next time around? Because I hear rumblings of it happening.
Okay, so that you see exactly that the Public Health Agency of Canada has been very actively seeking out the engagement with us since this summer, and so they have actually significantly beefed up their data science division, and for the monitoring and for any kinds of data monitoring, started from the weathers and then the wildfires and then the wastewaters and the border crossing, right? So there's things we collected massively, and during the COVID, and that's where they actually wants to learn as much as they can from the previous rounds of data collection. And hopefully, the data they collected, the insights they have from the previous rounds, will inform better for us to be prepared for the rounds to come. But it's not just the COVID, and then there's some other emergent infectious disease will for sure visit us in the future. So then they actually recognize the data, the big data, complex data is really the asset, the weapon. They can fight the disease a little bit better next time around. So that's where they actually interested in investing in this kind of technology, and they are very much promoting the open data, open science, hope that to enable the data scientists and everybody outside that agency, the locked wall, be able to contributing this endeavor.
Okay, so that's it's good to see this all pieces clicking together here. You mentioned Ottawa University Hospital, Ottawa Hospital, and the connectivity and the connectivity that UW has there. What about other hospitals? How do they, I won't say get on the bandwagon, but how do they get involved, or how do they start to learn and grow as this? Because they can't wait for it to just to be all done and then they start. How do they get going?
I think learning health systems and access to data is on a high agenda for everybody. So even a local hospital, the Grand River Hospital, and have a very strong desire uh, to have the insights from their data, and they also actively engaged with the professors here at the University of Waterloo, right? So in terms of using the layer of the synthetic data layer, and there's a few steps you can do. One is to obviously rely on the vendor solution. There's a number of vendors and out there, and they provide the data lake, they provide the better self-serving data exploring, and for the hospital, and plus they can provide the synthetic data layer for you to get exchange. So then, such as MD Chrome, they are using, that's where the Ottawa Hospital That product enabled Ottawa Hospital be able to share with us very easily the synthetic data. So there's a number of other installations like Nova Scotia and Jewish General in Montreal, and they all have the similar platform. So then they can share the data with each other easily, right? So we are also trying to reach out to the other hospitals and to see if we can build a pan-Canadian synthetic data network with the hospitals that they can exchange the data and exchange the data with us using the synthetic data mechanism.
Here we are today. It's in November of 23. You mentioned you have upcoming in February and April, different programs. Who are those programs for? Let's just do this as a bit of a wrap of, are these for researchers? Are they for hospital types? Who should be coming to this event?
Okay. For the algorithm hands-on workshop for data scientists, we were hoping that the data scientists interested or working on the synthetic data generation from the big agencies, StatsCan, CAI, and Public Health Agency, Ministry of Health, and if they want to come, because they are all developing their own algorithms, experimenting different algorithms, that's mainly to targeting them. Of course, Waterloo researchers and the well-being playing a central role, and the well-being share our experiences. And so to play a central role in that, they are welcome to attend as well. So that is in the February, very much hands-on at the data scientist, the targeted data scientist. We build an open data, open science on this topic, okay, from a technical part. Now in April, it's for the decision makers, for the agencies, for the hospitals and their privacy commissioners and their data science directors will come together to look at what is a guiding principle of we need to generate and then to actually share, to publish, to share the synthetic data. Okay, so we hope to build using the Delphi study and build the consensus of this is Canada standards. We agree upon this basic principle, and we are going to publish, generating and annotate our data in these standard terms. And we're going to follow these procedures to request the data, evaluate, and actually to prove its appropriate use. So that's what we were hoping to achieve from the April all the way to probably in the summer. Hopefully, we'll have a first draft to being signed off by all these agencies. And we also actually working with the Office of Privacy Commissioner's Office of Canada. They have granted us a grant to work on the data governance, fair and care data governance framework for synthetic data. So that is also the OPC, the Office of Privacy Commissioner of Canada. And it's also aware and sponsored actually the data governance framework.
Wow. So, Helen, you have pretty big shoulders here. Are you leading this initiative? Are you doing it as a team? Who's running this?
I am their secretary. I am just really a helper and secretary, and I think we have very fortunately we have a very strong data science team, and our Waterloo student is very impressive. I must say, just hands down. I just admire them and master PhD students, and they was carry on the major investigation development of the algorithms. It's very impressive. And also in those agencies, they actually have the vision. They also have very good data scientists working with us. In the Public Health Agency of Canada, they opened all their big computing platform and for us to carry out rounds and rounds of massive number crunching. Without those infrastructure, without a support from the very high top level of their leadership, their director generals, three agencies signed off this project to actually carry out the investigation. Without that level of support, these kind of initiatives will not take off. It's actually a very expensive initiative, to say the least. But
Well, thank you.
I'm very happy and very pleased. And also, all around, the people express their interest, as you said, Harold. And also, they allow us to work with them. It's just such a learning experience for all of us.
I'm going to take that as your final comments here. This has been incredible. Thank you for taking us on this tour of what's happening in synthetic data on the health side. And thanks for being part of Let's Talk AI today.
Yeah, but
Very
Harold,
appreciated.
one more closing comments is that I'm also very grateful for the AI Institute and the Cybersecurity Institute. Without you guys' support to even get us started, it was through the seed grants and through your sponsorship for the events we host, and actually through to the conference to bring us to Ottawa, and we will not have this exposure, and the project will not start. So thank you very much.
Okay, well, I'm going to follow up and get that in writing. Well, thank you so much. Thanks, Helen.
Yeah,
And thanks
you're
again
welcome.
today for being part of our podcast.
Thanks for having me.